The first step in determining the properties of any system is to define the system itself. Let's consider a container full of some fluid like water. Well, that's actually not good enough. We need to be very precise about where our system begins and ends, so let me draw in a rectangle. That rectangle marks the system boundary, so anything interior to the rectangle is the system, anything outside of it is not the system. We can imagine constructing a sample list of properties, so things like mass, density, volume, texture, pressure, temperature, flammability, specific heat, thermal energy, color appearance, total electrical charge, electrical energy density, melting, boiling, freezing point, magnetic electric field strength. Okay, there are a lot of properties. Now obviously, for every system, we don't need to list all of the possible properties we could ever think of, so let's imagine for this particular system we're really just interested in the top two, mass and density. So if we get rid of all the others, we can ask ourselves a very simple question. What happens if we change the system boundary? Does the mass increase or decrease? Does the density increase or decrease? Well, let's try it. Let's make our system bigger. What happens when we expand the boundary? Make the rectangle larger. Well, clearly we now enclose more of the fluid, so the mass has to increase. What about the density, though? Well, density actually stays the same in this particular example. Now, you might object and say, well, wait a minute, that's because we chose a rectangle that still encompassed water exclusively. What if our rectangle had instead been located up here and extended into the region above the water that conceivably could contain something like air? Well, here's where we have to be precise about what we mean by density. If we're just talking about this little point right here at the end of the arrow, that's still just the density of water, about 1,000 kilograms per cubic meter. Up here would still be the density of air. Now the average density of our system may very well change depending on whether our system is a mixture of both air and water. But if we're more precise and we just want to know the density at particular locations, well, that surely does not depend upon the system that we drew. So what we would say is that when we increase our system size, the mass increases, but density, again using this definition of just sort of a local density, stays the same. So we would refer to mass as being an extensive property, meaning that it does change with the size of the system, and is essentially the sum of all of the smaller system components, whereas density would be an intensive property. It doesn't vary with the size of the system that we consider.